video, we're going to focus on parallelograms, especially their area. One of the best parts of geometry is that formulas do not have to feel random. We can often see where they come from. That's what we're going to do here. We'll start by drawing several parallelograms with a base of 5 units and a height of 3 units like I have here. One of them is a rectangle, and we have two that are slanted, but they do still have the same base and the same height. Pause for a moment and look carefully. Even though the shapes look different, they all have that base of 5 units and a height of 3 units. Now, let's ask, what is the area of the rectangle parallelogram? Since it's a rectangle, it's easy to find. The area here would be 5 times 3, or 15 square units. Now, what about the other parallelograms? At first, students sometimes think a slanted edge must have a different area because it looks different. But this is where the geometric reasoning helps us. If I take this parallelogram and I'm going to imagine cutting it right here along this line. Then I'm going to take this triangle and I'm going to slide it over to the other side. When we do that, this piece right here is still here. This one over here has shifted here, and now we have a rectangle. And what are the dimensions of that rectangle? The base is still 5 units, and the height is still 3 units. So the new rectangle has an area of 5 times 3, which is 15 square units. And because we only cut and rearrange the shape without adding or removing any area, the original parallelogram must have also had an area of 15 square units. We can do the same for the other parallelogram. I could cut this line here and shift over and create a rectangle. No matter how slanted they are, if the base is 5 and the height is 3, the cutting and rearranging shows that each one has the same area as a 5 by 3 rectangle. And this gives us for the formula for the area of a parallelogram, which is base times height. It's very important to emphasize that the height is the perpendicular distance from the base to the opposite side. It's not usually the slanted side length. That is a very common student mistake. So if a student uses the slanted side instead of the height, that's a good opportunity to ask, does that segment measure straight up and down from the base? Is it perpendicular? Can it help us form a rectangle? These questions help students connect the formula to the geometry. As future teachers, it's worth noticing that this formula is not just something to memorize. It comes from a transformation. We take a less familiar shape and rearrange it into a rectangle, whose area students already understand. That is powerful teaching. Excellent work. You are not just learning a formula. You are learning why the formula makes sense. That kind of understanding will help you teach mathematics more confidently and more clearly. In the next video, we'll use a similar idea to find the area of a trapezoid.